Okay, using the substitution method, solve the pair of simultaneous equation. Solving by substitution is one of the most basic things you need to know in secondary maths. And it always looks like this. You are given two equations. All you need to do, always, very, very standard, take your pen, write down equation number 1, equation number 2. Okay? So from either equation 1 or 2, you make something the subject. You can make x the subject, you can make y the subject. If you are lucky, one of the equation already has something in the subject as x or y as the subject. Do we have it in this case? Y is the subject already, right, from equation number 1? So all we need to do is to substitute sub 1 into 2. Write this down. Sub 1 into 2. So what do I mean? Every time I see y, I will change it to become 2x. Okay? In my equation number 2, every time I see y, I change it to 2x. It's as simple as that. So after I substitute, this is what I arrive at. 10x minus, now it's time to substitute, right? Y minus y. And y, according to equation number 1, is the same as 2x. Must be equal to 4. Okay, do you see that I've substituted equation 1 into equation number 2? So this part, all the same. And this y over here is this. Can you see the substitution? Okay, so by doing so, I end up with one equation with one unknown. This is one equation with one unknown, which means I can solve using my Sec 1 maths. So 10x minus 2x becomes 8x equals to 4x equals to half. Now what do I do with this? I know the value of x already, right? I need to know the value of y. Times 2, y times 2. So this one, right? Sub into equation number 1. Make sense to you? Does it make sense to you? After I get the value of x, I sub it into equation number 1. Since equation number 1 says y equals to 2x, I know x already. So 2 times x must be y. Okay? So y equals to 2 times our half, which is 1. So answer, x equals to half, y equals to 1. Can? What does this mean on a graph? If we did not learn solving by substitution, this is what we would have done. X and y, 0, 1, 2, so 0, 2, and 4. This is for y equals to 2x. Then I'll have another table, x and y, 0, 1, 2. Then you find the values. Then you plot the graph, y equals to 2x. And then we've got another one. This is actually y equals to 10x minus 4. Y equals to 10x minus 4. Okay, so this is what we would have done if we don't have substitution method. I'll be plotting two graphs. Then I will be searching for the point of intersection, which is found here. Then I go down and see, oh, what's the x value? And what's the y value? Now that we have worked out the answer, can you tell me what's the x value over here? Now that we have worked out x and y, okay, so we expect this to be half. And what is this y value that we expect it to be? 1. If I were to plot a graph, this is what I will get. But it is very tedious. So we learn the substitution method. Can? You must know how to change between graph and the other methods. Well, okay, back to other question. Exercise number 3. Was it done for you? No? Then how come I have it here? Huh? I never record. Did I do this with you? Are you sure?
Yes.
Okay. So, okay, so this is what we have. Like I said, we always start with naming the two equations. Equation number 1, equation number 2. Standard stuff. You see simultaneous equation, name it equation 1, equation number 2. So, we always want to make something the subject, either x or y the subject. If you are lucky, one of them will have x or y as the subject already. Are we lucky over here? We are lucky, right? Equation number 2 has x as the subject already. So I sub 2 into 1. Okay, I'm going to highlight the standard stuff you always do. Sub something into something. Okay, so we see that in equation number, hang on, sub 2 into 1. Okay, equation number 2 is made up of, equation number 1 is made up of 5y minus 3x equals to 1. So 5y minus 3 something equals to 1. Now since my equation number 2, I've got x in terms of y. X is the same as 3y minus 5. And since I'm substituting inside equation number 1, every time I see the x, I will change it to 3y minus 5. So exactly what we have over here. This is the process of substitution. And now all my x disappears. Because every time I see x, I change it to 3y minus 5. So simplify, expand, get the value of y. Okay, because it is one equation with one unknown only. So get the value of y, substitute it back into equation number 2. You can choose to substitute into equation 1 if you like. But given a choice, you want to substitute into 1 or 2. You want to find the value of x. Do you want to substitute into equation 1 or equation 2? Equation 2, because it will give you the answer directly. I say again, you can substitute into 1, but you're just giving yourself a lot of work extra to do. Okay? But if you do that, you'll still get the same answer. So you just need to copy down this portion in red. Like this? Okay, thank you. So this is what we have. 4. This is a slightly different type of question, but the approach is still the same. I see simultaneous equation. What is the first thing I do? No, not sub. Equation number 1, equation number 2. Standard stuff. Okay? Now we try and find whether either of these equations has x or y as the subject. Have or not? Don't have, right? I have got x plus y is 24, 3x plus 2y is 6. I want to make either x or y as the subject. Which one do you want? You want x to be the subject? Sure. Do you want it from equation 1 or equation 2? Sure. From 1, x equals to what? From equation 1, x equals to what? Alright, sure or not? Negative 24 minus y. Very good. I call this equation number 3. Okay? Can? I call this equation number 3. What do I do now? Now that I have x equals to negative 24 minus y. Sub into which one? Sub into 1 or 2? Do I have a choice? You see, class, very important over here. Please look up, please look up. Don't substitute now first. Because if you miss this, you may make this mistake. Look up, look up. I got this from equation number 1, right? I got this from equation number 1. If I choose to substitute this back into equation number 1, for example, I sub back into equation number 1, I will get, every time I see an x, I change it to negative 24 minus y, right? So I see an x, okay, negative 24 minus y. Right, then I continue. What does it say next? Plus y plus 24 equals to 0, right? Then now I continue to simplify. Negative 24 plus 24. Oh, that's 0. Negative y plus y. That's 0 also, right? 0 equals 0. Does it help? Doesn't help. if you got it from equation number 1, you cannot sub back into equation number 1. You have two equations. You must sub into the other equation so that it works. So now I'll sub into equation number 2. Every time I see the x, I change it to negative 24 minus y. So in equation number 2, I've got 3 times of negative 24 minus y plus 2y equals to 6. I substitute it without thinking at all. Then now I expand and I work out the answer for y. So this is negative 72 minus 3y plus 2y equals to 6. I hope I did my mental sums correctly. Okay, I think it is correct. So negative y equals to 72 plus 6. Y equals to negative 78. Am I right? Okay, then what about x? Sub this one into which equation? Equation 1? 3? 1? 1 can work. 3 also can work. 2 also can work. What do you want to sub? 3 lah, because I already created equation number 3, right? I knew that this is going to happen. It's simplest. It's the simplest already. So sub into equation number 3. We've got x equals to negative 24 minus negative 78, which gives me 78 minus 24, which is 54. Checking at the side. Check. I will now have, okay, so the answer x equals to 54, y equals to negative 78. I will sub my answer back into equation number 1 or equation number 2 just to verify. So for example, I sub into equation number 2. 3 times x, which is 54, plus 2 times negative 78 equals to, so calculator, I'm hoping to get 6 lah, right? If I get 6, then it will be valid. So 3 times 54 minus 2 times of 78, and I get 6. Okay, so this is the left hand side, and this is the right hand side. So I know that this is a solution. Okay? Would you like to try the next one yourself? Okay, try it. Exercise 5 using substitution. Everybody, all of you can have different approaches, yeah? You can choose to make equation 1, something for equation 1 the subject. You can choose to make something for equation 2 the subject. Usually there will be some way that is easier. But you get to experiment and your assistance. I have equation 1 here and equation number 2. Do you want to make x or y the subject? You want to make x the subject? Okay, you want to make it from equation 1 or equation 2? Is there anybody who chose to make y the subject from equation 1? Why you all don't choose make y the subject? X is easier, really? Can you tell that making x the subject is easier? What about equation number 2? What if I choose to start from equation number 2? Would it be easy? No, right? But can it be done? You want me to show it to you? I do the difficult one lah. Okay? Let me start from equation number 2. From equation number 2, I want to make something the subject. What do you want me to make as the subject? X or y? Y. You think y more difficult, is it? Okay, fine. So I get 5y equals to negative 16 minus 2x. Okay? So I want to make x the subject. So, sorry, make y the subject. Y equals to negative 16 over 5. Wow, really looks very complex, huh? Minus 2x over 5. This is my equation number 3. Okay, I will sub into which one? 1 or 2? Sub into 1 or 2? 1. Because I got this from equation number 2. So I sum into 1. Then I get x minus 2 times of y. Every time I see a y, I'll replace it with negative 16 over 5 minus 2x over 5. And this is supposed to be equal to 1. Okay? So now I have to expand. X minus 2 times negative 16. I will get 32 over 5. Negative 2 minus times negative 2x, I get plus 4x over 5 equals to 1. Am I right? So now I don't want the denominator, I want to get rid of it. I multiply by 5 everywhere. So 5x plus 32 plus 4x equals to 5. Okay, so 9x equals to 5 minus 32, which is negative 27. This is 9x. So x equals to negative 3. Do you have that? Same? All same? No? Kenix, yours different. What is your x? Huh? Okay, later you check your answer. So x equals to negative 3. Sub into equation number 1. 1, 2 or 3? 3, yeah, because I already have in equation 3 y as the subject. So I substitute it over there. Y would therefore be equals to negative 16 over 5 minus 2 times of negative 3 over 5. To give me negative 16 plus 6 over 5 to be negative 2. Do you have that? So my final answer, x equals to negative 3, y equals to negative 2. So I've proven it to you now that whichever equation you start from, whatever you make as the subject, you do it correctly, you will get the same answer. But this way quite tedious, right? Right? I'm sure most of you chose to make x the subject, 1 plus 2y, sub into 2. Okay, sub into 2, 2 times of 1 plus 2y plus 5y equals to 16. 2 plus 4y plus 5y equals to 16. 9y equals to... Okay. Oh wait, this negative 16, huh? Negative 18, so y equals to negative 3. See, same. Okay. 2, negative 2. Y equals to negative 2. Over here. Same. So after that, I'll get x equals to negative 3. After I do the rest. Alright? Okay, now you can try so turn to exercise 8 now. It's the same. 2 equations. One of it will be equation number 1. The other will be equation number 2. Choose to make either x or y the subject. Okay, in either equations. So I don't see anything that is extra easy. So let me just start with equation number 1. From equation number 1, I don't like to see fractions. I like to get rid of denominators. There are different approaches you can do for this. So we've got, I multiply throughout by, for example, no. Okay, I still want to make x the subject. Let's make x the subject. So x over 5 equals to 1/3 plus y over 4. Okay? Then I get rid of the 5 in the denominator. So x equals to 5 over 3 plus 5y over 4. This is my x. I call this equation number 3. Sub into 2. So substituting it into equation number 2, you have to be very careful over here. X, in this case, is going to be 5 over 3 plus 5y over 4 divided by 2. This part. Okay, then plus y over 3 equals to 5 over 6. Looks complicated, but I'm sure you can do it. Okay, let's get rid of all the denominators. I'll multiply both sides by 6. So here, times 6. This side, times 6. So I get 5 over 3 plus 5y over 4 multiplied by 3 plus 2y equals to 5. Just a while more. So 5 plus 15y over 4 plus 2y equals to 5. So from here, 15 over 4 plus 2, how much is that? 23 over 4. 23 over 4, y equals to 0. Therefore, y equals to 0. Sub into 3. So x equals to 5 over 3 plus 5 times of y, which is 0, divided by 4, which gives me 5 over 3. Okay, so the answer, x equals to 5 over 3, y equals to 0.